Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to show you how to draw Lewis dot structures from formulas. So let's get into this. So I'm going to go through the steps for each of these one by one to show you how you can use the steps to go from the formula to the Lewis dot structure. So the steps are very important. If you follow the steps, you can't go wrong. So the first step is to add up all of the valence electrons for all the atoms. And so you're going to get the valence electrons from the periodic table from their group number, because the group number, the A group number, is equal to the number of valence electrons for each element. So phosphorus is in group 5, so it has 5 valence electrons. And each hydrogen has 1 valence electron, and we'll have 3 hydrogens, so that's going to be a total of 3. So I have 8 total valence electrons to use in my structure. So now the second step is to put the skeletal structure together. And so the way I do that is I have to first determine what the central atom is and then add everything to that. So normally it'll be the first atom, but not always. So I would assume here that phosphorus is the central atom. Also, you can go by the rule or the rule of thumb that the lesser electronegative atom is the central atom, and you can compare electronegativities. The other thing you can notice is that I have hydrogen and I have phosphorus. Hydrogen will never be a central atom because hydrogen only bonds once, and you need an atom that's going to bond more than once. And so since I have hydrogen and phosphorus, and since hydrogen is not going to be the central atom, then phosphorus has to be the central atom. Okay. Um, so here, and also you could do your Lewis um, dot symbol for each element, right? So I have 5 valence electrons. Notice I have 3 unpaired electrons. So phosphorus wants to bond 3 times, whereas again hydrogen only has 1 unpaired electron, so it's going to bond once. So the one element that's going to bond the most is going to be the one that you are going to have as a central atom. Another thing to look out for is how which element do you have less of? The one you have more of is usually not going to be the central atom, right? So here I have 3 hydrogens. I only have 1 phosphorus, so the hydrogens are going to be bonded to the phosphorus. So there's a lot of different ways in which you can verify or figure out what the central atom is. So here the central atom is phosphorus. I'm going to bond each of the hydrogens once to the phosphorus. And again, when you build your skeletal structure, you're only putting single bonds first. Double and triple bonds will come later in the later steps. Okay, now I have my skeletal structure. So now what I'm going to do is I'm going to subtract out from my total the electrons that I use. So for each bond, it's 2 electrons. So I have 3 electrons that I used. So I'm going to subtract out 6 electrons, and uh, I'm left with 2 electrons. So I have 2 electrons left. So that's the second step. Third step is if you have electrons left over, you're going to give lone pairs to the outer atoms to give them an octet if they need an octet. Now, if I look at the outer atoms here, I have hydrogen. Hydrogen doesn't need an octet. It's happy with just 2 electrons bonding once. So that step we can skip. Okay, so that's step 3. Step 4 is once I've given lone pairs to my outer atoms, and if I still have electrons left over, all of the electrons left over will go to the central atom as lone pairs. So here I have 2 electrons, so I have 1 lone pair. So I'm going to add the lone pair to the central atom. I've used up all of my electrons, so I have no more left. So that's step 4. And then here, once I've used up all of my electrons, I double check my structure that I have so far to see if everything is happy. If all of the atoms are happy with what they've got, then I'm done. But if they're not happy, then usually it's going to be the central atom that doesn't have an octet and it needs an octet, right? So here, I double check each hydrogen is happy with a single bond, that's 2 electrons. And then here for my phosphorus, I have 3 bonds, that's 6, plus the lone pair, that's 8. So phosphorus is happy with 8. This is done. So this is my Lewis dot structure for pH3. Now, the 5th step, which we didn't need to use, if my central atom at this point does not have an octet, and it needs an octet, then at this point, what I would do for step 5 is I would take any lone pairs from my outer atom and move them to create a bond, a double bond or triple bond, in order to give my central atom that octet. So that's it for this one. Also, for the problems I'm going to be doing here, it won't apply, but for more complicated problems, you might use formal charge to figure out which Lewis dot structure is the best. I'm not going to be doing anything with formal charge in this video, but I do it in other videos, so you can check out my other videos where I deal with the more complicated issues of expanded octet and formal charge and stuff like that. So go and see that video if you're interested in that. Okay, so that is A. Why don't we do B? So I'll give myself some room down here. So B, HOCl. So the first step is to tally up the total number of valence electrons. Hydrogen is in group 1, so that is 1 electron. I have an oxygen that's in group 6 that has 6 electrons, and I only have 1 oxygen, so I'm going to add to that 6. And I have 1 chlorine, that's going to be a 7 because it's in group 7, so it has 7 valence electrons. I add that together, and I get a total of 14 electrons. Okay, that's step 1. Step 2, central atom. So here, again, hydrogen is not going to be the central atom because it likes to only bond once. Oxygen likes to bond twice, so it would bond to these two. And chlorine only really likes to bond once. So in this case, halogens tend to be your outside atoms, not your central atom. So in this case, I would choose oxygen. Now, if we're comparing the electronegativity, then we would see that chlorine is more electronegative than oxygen. Oxygen, being the lesser electronegative atom, would tend to be the central atom here. So we're going to choose that oxygen is the central atom. And so here I have oxygen in the middle. So step 2, I'm going to put my, excuse me, I'm going to connect the other 2 atoms by single bond. So I have my Cl and my hydrogen. And so now I have the skeletal structure. That's step 2. I have to subtract out the electrons I used for the bonds. So that's 4. So I'm going to subtract out 4. And that means I have 10 electrons left over. So the third step is I'm going to add lone pairs to my outer atoms to give them an octet if they need it. Hydrogen doesn't need an octet. It's happy with a bond. But chlorine needs an octet. So I'm going to add 3 lone pairs to the chlorine. So now chlorine has an octet. It's happy. So now I'm going to subtract out the 6 electrons that I used from my total. So I'm going to subtract out 6 and I have 4 electrons left over. Okay, so now that I have that completed, I have 4 electrons left over. I'm going to go to step 4. Step 4 says that if I have electrons left over, I add all of those electrons to the central atom as lone pairs. So I have 4 electrons left over. That means I can put 2 lone pairs on my central atom. So here we go. So I've used all of my electrons. So I have no electrons left over. At this point, I double check my Lewis dot structure, make sure everyone's happy with an octet if they need it. Oops. Sorry about that. All right, so who's happy? Hydrogen's happy with 1 bond, so that's good. Oxygen has 2 bonds, that's 4 electrons. 2 lone pair, that's another 4, so that's 8 electrons. And chlorine has 1 bond, that's 2, plus the 3 lone pairs, that's 6. 6 plus 2 is 8. So everyone's happy. So I am done. This is my Lewis dot structure. Again, I don't need to do step 5 because everyone's happy at this point. I don't need to make any double or triple bonds by moving lone pairs around. All right, let's do C. C, again, I have this formula. I'm going to add up, first step is add up the electrons, the valence electrons. So carbon has 4 valence electrons because it's in group 4. Chlorine, again, is in group 7, and I have 3 of them. So 3 times 7 is 21. And I have fluorine, which is also in group 7, and so that has 7 valence electrons. So that's going to be 21 plus 7 is 28, plus 4 is 32. Okay, so 32, I have 32 electrons. Now, second step, skeletal structure. So, again, several ways to look at this. The lesser electronegative atom is the carbon, so I would suspect that that would be the central atom. It's also the one written first, which again, usually the central atom is written first. And also, fluorine is not going to be the central atom because it only bonds once, and chlorine is our halide. So halides have a tendency of not being central atoms, so we wouldn't expect that. Although it's not unheard of, chlorine might be a central atom in some molecules, but in this one, most likely it's going to be the carbon. So we're going to set up our skeletal structure like so. Again, I want to remind you, you could do the Lewis symbol that I did before and see which element has the most unpaired electrons. And so the one with the most unpaired electrons would most likely be the central atom. And in this case, carbon has 4, which is the most unpaired electrons you can have for the Lewis dot symbol. So again, central atom. And then I'm going to add my atoms. So I have chlorine, 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 and I'll put fluorine there. So there's my central atom, or there's my skeletal structure. And so I'm going to subtract out the electrons for each bond. So 2 for each bond, 4 bonds, that's 8 electrons. So I'm going to subtract out 8 electrons. So subtract out 8, and then that means I'm going to bring it down here for room. So that means I have 24 electrons left. All right, step 3. I need to put lone pairs on the outer atoms to give them an octet if they need it with the electrons left over. So fluorine and chlorines all need an octet, so I'm going to add lone pairs. So 3 lone pairs to each of my outer atoms. So 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so that's Now they have an octet each, so now I have to subtract out all of the electrons. I use 6 electrons for each one. I have 4. 4 times 6 is 24. So I'm going to subtract out 24. I have 0 left over. So the next step, step 4, says that if I have electrons left over, I would add those to the central atom as lone pairs. I don't have any more left over, so I'm done at this point as far as electrons go. Now at this point, I double check to make sure everyone's happy in my Lewis dot structure. So each of the chlorines have 3 lone pairs, 1 bond, so that's 8 electrons. So 8 and 8. Fluorine also has 1 bond and 6 electrons, so that's 8. So all of the central atom, all of the outer atoms are happy with an octet. Carbon has 4 bonds, that's 8 electrons. So everyone's happy with an octet, so I am done. This is the Lewis dot structure for that molecule. Okay, last but not least, I have C2H6. So let me erase, give myself some room here. So once again, add up the valence electrons for the total. So I have C2H2. So carbon is in group 4. So that's 4 valence electrons times 2 because I have 2 of them. So that's going to be 8 electrons plus hydrogen is in group 1. It has 1 valence electron. So that means I'm going to have 1 each. So that's going to be 2. Add that together. I got 10 electrons. Now, this is an organic molecule. I have carbons and hydrogens. It's a hydrocarbon. In this case, we're going to have multiple central atoms. And so since hydrogen only bonds once, the only option is carbon. And I have 2 carbons. So they're both going to be a central atom. So I bond those together. So in my skeletal structure, the carbons will be bonded together. So this is the way my skeletal structure is going to work. Now, as far as where the hydrogens are bonded, symmetry is key here. So if you can make your molecule symmetrical, do it. Unless there's a reason not to, or there's a clear reason why you know that those 2 hydrogens are not separated. So I put them on each side. So there's symmetry in my skeletal structure. So now that I have my skeletal structure, that's part 2. I got to subtract out the electrons from the bonds. I have 3 bonds. That's 3 pairs of electrons. That's 6 electrons. Subtract out 6, and I've got 4 electrons. Oops. Yep, that's right. No, my bad. So yeah, so I have 4 electrons left over. So now what do? I go to step 3. Add your lone pairs to the outer atoms to give an octet. Well, the outer atoms are hydrogen. So for this case, hydrogen doesn't want lone pairs. So now I skip that step and I go to step 4. Add lone pairs to your central atom or central atoms. In this case, I have 2. And again, symmetry. I have all my electrons I'm going to add to the central atoms as lone pairs. So since I have 4, that means that's 2 lone pairs. I'm going to put a lone pair on each carbon. Again, symmetry. All right, so now I've got that. I've used up the 4 electrons. I've got 0 electrons left. Now I double check my skeletal structure. Is everyone happy with an octet? Well, hydrogen is okay with a bond, so they're happy. But look at the carbons. The carbons have 2 bonds and 1 lone pair, and that means they only have 6 electrons. They want to have 8. So what do? So in this case, I have to move a lone pair to allow for the carbons to have their octet. So here, I can move this lone pair there, and then that would give a double bond, right? So in this case, the double bond, if I write that out, I'll get a double bond C with a lone pair like that. Now notice that this carbon now has an octet, but this carbon still does not have an octet. So I gotta move more lone pairs. So the only lone pair I've left is this one. So I can move that one, make a triple bond. And so now I have that structure. And now look, each carbon has 4 bonds. So that is that's going to be good for this carbon. This carbon has 4 bonds, so they all have an octet. So this would be my Lewis dot structure. The other thing I want to point out is bonding patterns. So you'll notice that in each of the Lewis dot structures, these elements have their bonding patterns, right? Hydrogen bonds once. Carbon likes to bond 4 times. Phosphorus, like nitrogen in group 5, they like to have 3 bonds and 1 lone pair. Again, carbon, 4 bonds. Your halides like to have 1 bond and 3 lone pairs, right? So that's another way that you can double check to make sure that everything is fitting the bonding patterns. However, bonding patterns are not always followed, but it's good to double check. Ladies and gentlemen, that's it for this video. I hope this is helpful. If you enjoyed the video, if this was helped you learn your Lewis dot structures, then please, by all means, like the video, share the video with your friends, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think, ask me questions. If you have a video or a topic or a problem you want me to solve, I would love to do that for you. Thanks for joining me and have a great day.